All right, so let's look at the rules for indices. Okay, so indices are just simply powers, okay, or exponents on numbers. Okay, so rules for indices. The first one is if, for example, I have a to the power x being multiplied by a to the power y. This is the same as, okay, so the base here is the same. So this here, the a, the big number here, is what we call as the base. Okay, so these are the bases, and then these ones here are the indices. Okay, some of you call them the powers, some others call them as the exponents. Okay, so the first rule is that if I have two numbers being multiplied that have the same base, then I can simply add their powers. So this one here is the same as a x plus y. Okay, and then if I'm dividing ax divided by ay, it's the same as I subtract their powers. So this will be the same as a x minus y. Okay, so take note of these rules because we'll be using them. And then if I have something like a to the power x, okay, which is also raised to another power, I can simply multiply this power with this power. So what I get is a x y. Okay, and then another important one is a or any number being raised to power 0. Okay, so if any number is raised to power 0, we know that we are going to get what? 1. Okay, what about if a is raised to a negative number like negative x? Okay, so if you have a to the power negative x, this here is the same as 1 over a to the power x. All right, so the last important rule that I'll mention is the one that has to do with a fraction power. Okay, so for example, if I have a, okay, I have a, and then I have x. I have a power x over y. In short, the power there is a fraction. Okay, this one here is the same as, okay, the y-th root of this a, okay, and then I multiply. I mean the y-th root of this a, and then I raise it to the power x like this. Okay, so a good example of this is 25 to the power half. 25 to the power half. Okay. This number on in the bottom of the fraction becomes the root, so it will be the second root, or we call it as the square root. Okay, we don't usually show the 2 there for the square root of 25, and then I raised all this to the power, the one which is on top there. So this is just basically the square root of 25, which is what? 5. Okay, so when you see 25 to the power half is the same as square root of 25. Okay, what if I have 9 to the power half? This here is the same as the square root of 9, which is just 3. Okay, um, what if I have, okay, I'll write here on top. What if I have maybe b to the power, okay, let me use a number. So what if I have 5 to the power, let's say 2 over 3. Okay, so this one here will be the 5th root. Okay, I mean it will be the cube root of 5. Okay, and then I raise all this to the number which is on top there, which is what? 2. So take note of these rules because we are going to be using them in the next question that we'll be doing. Okay, so now let's go to the question and then try to apply these rules. Okay, so the next question, this is just basically simple algebra. Okay, so they're saying evaluate each of the following expressions. So the first one, you can see it there, is 25 to the power half. The one that I'm just from explaining. Okay, so this one here is the same as the square root of 25 and then raised to power 1. Okay, so this 2 here is the one that has become the square root. So it is the square root there. Okay, and then this one is the one which is there. So the square root of 25 is just basically what? 5. Okay, what about 2? So if you have any question, just ask. Okay, so 2, we have been given 1. Okay, that's a mixed fraction, 9 over 16, and then to the power 3 over 2. So that is what I've been given. Okay, so what you want to do here is first express this mixed fraction, okay, as an improper fraction. So how do you do that? Okay, you say 1 multiplied by 16, I get 16. And then 16 plus 9, okay? So I'm going to get, inside the brackets there, I'm going to get 16 plus 9, I'm just going to get 25. And then I divide this by 16. Okay, the same thing there. And then to the power 3 over 2. So now remember we said the one in the bottom becomes the root, right? So this will be the same as the square root, because I have 2 there, of 25 over 4. And then I raise all this to the power what? 3. So what am I going to have there? Okay, so remember the rules of surds. We said if you have something like this, then we can separate. So it can be the root of 25 divided by the root of what? 16. So you've seen how things are adding up. So if you don't know these rules, you just get confused, okay, when things are very simple. So now the square root of 25, we know it's 4. Okay, the square root of, I mean, yeah, Hanan much. I've started lying. The square root of 25 is 5. Okay, I was thinking a step ahead. And then the square root of this 16 is the one which is 4. And then I'm raising all this to the power 3. Okay, so 5 power 3 is simply what? Okay, it's simply 5 multiplied by 5 multiplied by 5. Okay, so this power goes to the 5, it also goes to the 4. So even in the bottom, it will be 4 times 4 times 4. Okay, so 5 times 5 is 25, then 25 multiplied by 5, I get 125. Divided by 4 times 4 is 16. 16 times 4, I get 64. So this is the answer. Okay, so I've simplified this thing here to just this thing. Okay, so any questions there?
No.
Right, so let's look at the third one then. Okay, so I'll leave some for you guys to solve on your own. So you can try them and then you send me the answers. Okay, so let's look at this one. So this one we have 343 over 512. And then this is being raised to the power minus 2 over 3. So remember the rule for the negative power. We said if I have a minus x, it's the same as 1 over, okay, a to the power positive x. So this is what we're going to do. We're going to say this one is the same as 1 divided by this same thing, but now raised to a positive power. So this would be 343 over 512. Okay, 512, and then raised to 2, 3. Okay, so this will become 1 divided by, this one now become the root. So here it will be the cube root, okay, of 343 divided by 512. And then I'm raising all these to the power 2. Yeah, so that's what I'm going to get there. Okay, so what is going to happen there now? Okay, what is going to happen there? So we're going to find the cube root of those numbers. Okay, so you can confirm with your calculators. Okay, but the cube root of 343 is simply 7. Okay, so 1 divided by, so the cube root of this one on top is 7. Then the cube root of 512, okay, it's 8. So I'm going to put 8 there, and then squared. So this is what I have. And then from here, what can I do from there? I can actually square these numbers. So I will say 1 divided by 7 squared is 49. Okay, 8 squared. Okay, you can confirm with your calculator, 64. So now I have 1 divided by this. So this I can change it to 1 multiplied by 64 over 49. So it means the answer there will just be 64 over 49. So we have simplified, okay, this to that guy there. Right, so any questions, you're welcome. Okay, but if there are no questions, I'll solve this last one. Okay, and then I'll leave the other 4 for you guys. Okay, so you can try them out. You can share your solutions with me, and then I'll be able to guide. Okay, so let's look at this one. So this is 125 to the power 4 over 3. Okay, so this is basically the cube root of 125 to the power 4. So what is the cube root of 125? Okay, so the cube root of 125 is it's 5. Okay, remember we did 5 times 5 times 5, we got 125. So it means this cube root here is 5, and then to the power 4. Okay, so 5 to the power 4. Okay, so it will be 5 times 5, it will be 25. 25 times 5 to be 125. And then 125 times 5, it will give you 625. Okay, so that's our answer there. Okay, so these are basic and very simple. So try this one, this one, this one, and this one out. Okay, and then you can share the solutions with me. Right, so let's look at B now. Okay, so we are still dealing with exponents. Okay, so I think I'm going to end on B here for today. We're still dealing with exponents here. Okay, so here now they're saying simplify each of the following expressions fully. So I have this one as the first one. So the rule that governs this, I said if I have a to the power x and then to the power y, it's the same as a x to the power y, like that. Okay, so here what I'm going to do is that x to the power 6 and then to the power 1 over 3, I have to multiply this 6 with this 1 over 3. So I have x 6 multiplied by 1 over 3. So this will just give me x squared. Okay, so that's basically the answer there. So the answer is just x squared. 2, we have the root of 2, and then x to the power 3 divided by, there we have the square root of 32 over x squared. Okay, so anyone who has an idea what we can do here? What can we do to simplify this expression? Anyone who has an idea what we can do to simplify this one? Okay, so we go back to SADS, the first topic. So here what we want to do is make this root of 32 to have a root of 2 somewhere so that it can cancel with this one. Okay, so what we're going to do is that I'll write root of 2 and then x to the power 3 just the way they are. And then I have to manipulate these guys here. Okay, so I have root of 32 over x squared like this. Okay, so by the laws of SADS, we said we can distribute this root. Okay, I can have the root of 32 divided by the root of x squared, right? If you remember. Okay, so this 32, let's look for two numbers such that when you multiply them, okay, they're going to give you 32, but one of those numbers should have a perfect square root. Okay, so those two numbers for 32 are going to be 16 and 2. Okay, so that 32 on top is going to be the root of 16 multiplied by 2 over, and then this square root of x squared just becomes x because the squared and the roots they cancel. Okay, and then on top there, what I'm going to have is that I'm going to have square root of 16 multiplied by the square root of 2 over x. So square root of 16 is 4, and then I have the square root of 2 over x. Okay, so this part here, okay, this part here has become this. So I'm just going to write 4 root of 2 over x. Okay. Okay, so we have root of 2 and then x to the power 3. And then here, this one, we can change it into a multiplication. Okay, so this x goes up, this one comes down. So I have x there over 4 root of 2. So you see now that I can put this over 1. And then I can cancel out the root of 2 and the root of 2, they go. Okay? And then now I can multiply. X to the power 3 multiplied by x, I get x to the power 4. And then 1 multiplied by 4, I get 4. So we have simplified it fully like that. Okay, so any questions there? Okay, so as you can see, as we are solving the questions, we are simply connecting the dots, okay, from the simple concept that we learned, okay, to the algebra that we are doing today. So imagine now if you don't know how to do this about SATs, how are you going to simplify that one? Okay, so know the basic rules there, and then it will become simple for you to do anything. All right, let's look at the third one. Okay, so the third one is this one. So I have 3x to the power 4 times 2x to the power minus 5. So here what we have to use is that one for the negative power. So we said a to the power minus x is the same as what? 1 over a to the power x. This is what we said. So let's change this guy here into this. So I'm going to have 3x to the power 4 multiplied by 2 multiplied by this x to the power minus 5. I'll write it as 1 over x to the power 5. Okay, so if I do that, I see that I can cancel x to the power 4 there, and I can cancel x to the power 4 here, meaning I'm just going to remain with what? X. Okay, because 4 of those x's have cancelled with this. But if you don't want to do it directly, you can simply say 3 times x. Let me use dots for times. Okay, 3 times x times x times x, like you agree 12 times x, and then times 2 times 1, and then we're dividing all this. Here, what's happening? We're dividing all this by x. Okay, x dot x dot x dot x dot x, and then you just start canceling one by one. So this one and this one goes, this one and this one, this one and this one, this one and this one. So I remain with 3 times 2 times 1, which is 6, and then here I remain with x. So it will just be 6 over what? X. Or you can write it as 6x to the power minus 1 like this. Okay, so that is it there. Okay, that is it there. Let's look at the fourth one. So the fourth one, we have 4b squared times 3b cubed times b 4. Okay, so let's multiply first of all the constants. So I have 4, I have 1, and then I have 1. I have 4, 3, and then here in front of this b to the power 4, I have 1. So 4 multiplied by 3 multiplied by 1, I get 12. And then I have b to the power 2, b to the power 3, b to the power 4. So remember we said if I have the same base like that, and I'm multiplying, okay, and I'm multiplying, we said you can just add their powers, okay? So it becomes ax plus y. So that's what we're going to do here. We're going to write just one b, and then we're going to say 2 plus 3 plus 4. So this is going to give me 12b, okay, to the power 9. So this is the final answer there. Okay, so I hope you get the concept now. You can do the rest. Okay, so you can try out this one and also try out this one, and then share the solutions with me. I'll be able to guide if you're having any challenges. Okay, otherwise for today, I think that is enough. We've covered something. Okay, so are there any questions before I close the class? Okay, no questions. All right. So I'm going to continue solving this tutorial sheet. Okay, I've just ended on question 2B. Okay, but we have a lot of questions here. Where's the okay, we have a lot of questions in this tutorial sheet. Okay, so this is the tutorial sheet here. So we've done one here, 1A, 1B. Okay, we've finished question 1. Okay, so we started with question 2A. We've done this one. We've also done B. Okay, so I'll continue making the videos. Okay, I'll make a question 2, C, D, E, okay, until I finish all the questions that you can see here. Okay, so I'll upload that video on our website. You can access it from the website and the mobile app, and some of them I'll also post them on YouTube. Okay, so otherwise, Thank you so much and have a blessed night.